Hello everyone and good day dear viewers. I am Miss Rachel June M. Bantilan, a second year best mathematics student. Today I am going to discuss the second topic that I best learned through the semester from the subject Math 204 Probability Theory. And this topic is from Chapter 5, Section 5.1, which is all about Introduction to Normal Distribution and the Standard Normal Distribution. In this topic, we are going to interpret graphs of normal probability distributions and find areas under the standard normal curve. Continuous random variable. It has an infinite number of possible values that can be represented by an interval of the number line. Example is the number of hours spent using cell phone the whole day. So here the time spent is 14 hours. Continuous probability distribution. It is the probability distribution of a continuous random variable. Normal distribution. It is a continuous probability distribution for a random variable x. The most important continuous probability distribution in statistics. The normal curve is the graph for a normal distribution. So here are the properties. For number 1, the mean, median, and mode are equal. Second, the normal curve is bell-shaped and symmetric about the mean. Third, the total area under the normal curve is equal to 1. Fourth, the normal curve approaches but never touches to x-axis as it extends farther and farther away from the mean. Fifth, between mean minus standard deviation and mean plus standard deviation, in the center of the curve, the graph curves downward. The graph curves upward to the left of mean minus standard deviation and to the right of mean plus standard deviation. The parts of which the curve changes from curving upward and curving downward are called the inflection points. A discrete probability distribution can be graphed with a histogram. In continuous probability distribution, you can use a PDF or probability density function. The properties are the total area under the curve is equal to 1, and the function can never be negative. Mean and standard deviation. A normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line symmetry, and the standard deviation describes the spread of the data. By looking at this graph, the curve A has a greater mean because the line of symmetry of curve A occurs at x is equal to 15, while the line of symmetry of curve B occurs at x is equal to 12. And for the standard deviation, curve B has a greater because the curve B is more spread out than A. Standard normal distribution is a normal distribution with a mean of 0 and the standard deviation of 1. The total area under its normal curve is 1. Any x value can be transformed into a z-score by using this formula. Z is equal to value minus mean all over standard deviation. So the properties are first, the cumulative area is close to 0. For z-score close to, z is equal to negative 3.49. Second, the cumulative area increases as the z-scores increases. Third, the cumulative area for z is equal to 0 is 0.5. And fourth, the cumulative area is close to 1 for z-score close to z is equal to 3.49. So here are some examples on finding area under the standard normal curve. First, sketch the standard normal curve and curve the appropriate area under the curve. Second, find the area by following the directions for each case shown. A. To find the area to the left of Z, find the area that corresponds to Z in the standard normal table. So here our example, the area to the left of Z, which is equal to 1, is 0.8413. B. Find the area to the right of Z by using a standard normal table to find the area that corresponds to Z, then subtract the area from 1. So we have here our area of 1 is equal to 0.8418. So when we subtract it from 1, 1 minus 0.8413 is equal to 0.1587. Letter C. Find the area between two z-scores. Find the area corresponding to each z-score in the standard normal table. Then subtract the area or the smaller area from the larger area. So we have here the area to the left of z, which is equal to 1, and the z-score is 0.8413, and our second z-score is negative 2, which is equal to 0.0228. And when we subtract this, the answer is 0.8185. So that's all for today's lesson. I hope that you enjoyed my discussion, and I really hope that I explained it so well. For more educational videos, please subscribe to this channel. Stay safe, God bless, and thank you. Bye-bye.